Hello, welcome back from lunch. Hope you enjoyed lunch. So we've got two sessions up here before afternoon tea. First up, we have Tom here, who's going to be talking about Are You a Bad Enough Dude to Take Down Your Network, which was probably my favorite talk title when I was skimming through all the talk titles to go to. Tom is an SRE at Canonical. Before that, he was a network admin. He's been mostly spending his time working on Trigger, which is what he's going to be talking about today. So I'm just going to, without further ado, hand it over to Tom and we'll get cracking.
Sorry about the slides. It's a vintage mode today. It's meant to be green. My name's Tom. This is something I work in my spare time, and it has no affiliation with what we run in production in Canonical. So if you destroy your network, don't blame Canonical. All right. Are you a bad enough dude or dudette to take down your network? Hands up who is. All right, that's good. I'm hoping by the end of this talk, you'll be able to pick up the world's fastest network destruction utility. And for those that are not, that's okay. Your secret's safe with me. So I want to start off and talk about traditional network automation and how it leaves a lot to be desired. So to protect network operators from themselves, vendors started shipping these systems with just the bare essentials. So these were a series of verification commands, utilities, against to verify the state of a machine. So in the Cisco world, these were called as show commands. And partnered with these were a series of configuration modes for subsystems of the box. So you would have a mode for configuring your routing protocols like OSPF or BGP or the interfaces themselves. And the interface to this was a VTY line. At first this was Telnet, and then later came SSH. And this sounds pretty secure, right? It's a closed box, but that is until it's not really secure. And this isn't limited to just one or two vendors. Exploits and bugs are basically a fact of life when dealing with technology. But the tools needed to manage this, as in tools like live kernel patching and archive mirrors, don't normally exist in the network space. And this is a space where manual code upgrades or doing ACL-based mitigations to threats are basically the norm. All right, so given this unique platform, how the hell am I meant to be a bad enough dude if I can't pipe those curl one-liners into bash? There's got to be something I can do, right? Well, in the 80s, we saw the first attempt at a programmatic interface. We can probably guess what this is, right? SNMP. It didn't really take off for automation, but it's been pretty popular for monitoring and for people getting owned by leaving the default public string. A second attempt was made 10 years ago. This is netconf. Netconf has been getting some traction in the carrier space in particular. I'm going to talk more about that later at the end. There were some other attempts like providing TCL engines and Python interpreters on the box, but they didn't really take off. So at this point, engineers are essentially left with three automation options. So the first option, and the oldest configuration management system there is, the Notepad. Ginger templates, real engineers know how to rock, find and replace. And what tool do we use to deploy our configuration changes? Well, we use the clipboard. This method is pretty fine in bringing down a network. It's slow. I mean, you can only really have so many terminals open at once, and you basically really only have one clipboard buffer to work with. So this brings me to option two. This is using stuff like Perl and Expect based automation libraries. So for those not content with a rate of copy pastes per second, we turn to the only other technology as insane as the operating systems entrusted into our care, Perl. With Perl, we were able to automate the sensation of telnetting. That's right, telnet, because security had no place in automating Cisco devices with Perl until 2015. Into our devices, pasting a whole bunch of unvalidated lines of configuration into our session is basically just like Notepad automation on crack. And are there any security guys in the room? Okay, well, if there were, or if you're thinking about being a security guy, next time you pop a Bastion host, have a recursive grep around with some Perl network automation scripts because they're pretty much a goldmine for hard-coded credentials. So the last method I want to talk about is enterprise software. So basically, for $100,000 in licensing, the software must do everything, right? Well, it still involves a significant amount of consulting hours, and consulting hours means consulting money. And once the consultant's gone and the money is gone, and it's been handed over to the ops team to manage, there's no tool out there that's going to be smart enough in stopping that late night change engineer from accidentally deploying the wrong access control list to every router. So can anyone tell me what's common amongst these three methods? That's right, human error. Every one of us in the room has been that guy at some point. You can probably guess that late night change engineer was in fact me. So who here has a good human error story that I want to share? Not game enough? All right. Well, whether it's copy and pasting your pre-ASA 8.3 NAT configuration template into your shiny new Cisco next-gen firewall, or iteratively destroying all your out-of-band management ACLs because your little IP address passing regex was just one character out, or spending 40 grand on just a CentOS 6 virtual machine that basically just does SNMP walk. Now, human error is certainly a popular method of bringing down stable production networks, but I've been working on a more efficient way. Well, maybe not that efficient. So Trigger is a robust network automation framework written in Python. It's built for interfacing with network devices and managing network configuration. Presently, Trigger manages production network environments with thousands of devices. It allows you to fail fast, and fail often, because that's basically the DevOps mantra, right? It supports multiple vendors and platforms. It's open source, and pull requests are most definitely welcome. All right, but let's have a look at what it can do. So this is our lab environment. It's standard sort of MPLS network. I'm not going to go too much into detail about it, so we'll just jump over into our workspace here. All right, so who here has been on the phone to Cisco TAC or JTAC or something of the sort? So normally when you're on the phone to the TAC and you're dealing with a bug or something that's going on, they might ask you to run show tech support on all the devices that they feel are affected. So you might have 15 devices, you might have 100 devices, and the way that I've done it in the past is I've logged onto each device, just pipe the output out to T, and set it to a file, and box it up and send it to them. You might do it other ways, but that's the way that I've done it. So what if I told you that you could essentially just do that in maybe like 7 seconds? So with Trigger, we can have a script. We can have our command runner run. And we can, in roughly 7 seconds, it's probably 6 seconds for the network I/O, maybe roughly about a second to serialize that to the disk. We can grab show tech support from all our devices in that network, or all the provider core devices in that network. So as you can see, it's not a huge amount of data, but it's not a small amount of data, and it's across multiple devices. So the next thing I want to show you is using Trigger to do something pretty novel, I guess, is so using Trigger to visualize the path a packet will take through a network based on the source and destination address. Cheers. So just using some common tools, like here we're using Juniper and GraphViz. We're using some of the subsystems of Trigger in this example, we're going from like a single adjacent hop. So let's just run that. And so it's pretty boring, that output, but what if we wanted to trace the path from one end of our network to the other? So what we're doing here is we're sort of grabbing the output of the dumping the routing table with show IP route in the Cisco world, and then we're using some CLI output passing modules to then return structured data. And with that structured data, we can then program against that. So here we can sort of visualize, okay, it's going from the top of our network at the PE1 device, is getting to to the core, and then there's some multi-pathing going on. We were able to visualize that pretty easily. Cool, so let's just verify what we've done. So I'll talk about Gong. Gong is sort of like a drop-in replacement for OpenSSH client. It uses Trigger in the back end. And what's cool about Gong is that we can do things like cache our credentials, so we don't actually have to provide them with the login prompt. We can do other things like have a series of startup commands that we can run as soon as we log in, which is something I'm going to show later on in the next demo. But let's just take a look at that first PE1 device and just look at the route that it's taking. So as you can see, it's just going out that one interface to get to the other end. The other end is 2020. So going out of interface 7.3. So we'll jump on the Proprietor 1 device and just check its interface table. So as you can see, 7.3 again, there's that IP address that it was next top, 002. And won't do this on all devices, we'll just check the routing table. There's a multipathing, and we'll just trace route. And there you can see, it's actually taking multiple paths through the network, and using trigger, we can then pass that information really quickly instead of SNMP, where you're polling each device manually, and then processing it and doing something quite interesting. All right. Cool. So, hopefully this works. This hasn't worked. All right. Hang on. Sorry. Okay, so basically to recap, what we did was using trigger, and that's the code there. It's pretty simple. We're just basically overriding a class. It's called commando as the transport runner, as the command runner, sorry. We just give it the iOS command that we want to run, and we'll be saying, well, the vendors need to be Cisco devices as a filter. Pass it through a device list on they're the devices that we want to run that command against. And yeah, roughly 6 seconds probably from the network I/O to do that, and a little bit of overhead for serializing the output to a disk. So the other thing we did was doing the visual route pathing. So the library that we used to do that was called TextFSM. That's a Google library. It's open source as well. And basically all it does is it takes unstructured data. You could even use stuff from like a Linux command line prompt. And you give it a sort of a template language. I'll show you what that looks like in a minute. And then you get structured data back. So that's, for that visual route pathing, that's the trigger code required to do that. Pretty easy. There's a lot of other dodgy code that I wrote to get the the GraphViz stuff going, but we won't look at that. So that's the TextFSM template. It's pretty verbose, but I'll just sort of run through it. The values at the top sort of are your keys to a Pythonic dictionary that you get back, and then the regular expressions next to it are basically defining what state the values can be in. Everything under that routes there is sort of is going through each line and building the record based on the regular expressions there. And then yeah, it gets put under the key there as a value. And so you get like a Pythonic object back that's like that just from running a simple show IP route command, which is pretty good because the output of show IP routes not that great. All right, so trigger is a framework. It's laid out similar to how Django is laid out. It's comprised of credential management, which is what we saw Gong use previously. Command scheduling, which is, as we saw, the commando class there. Various transports, so we have telnet, SSH, and if you have API devices, then we've got, for example, JunoScript. Advanced filtering of device sets, so this works similar to how Django filters models. So with some of the metadata that we have on our device models, we can build interesting device sets based on state information that we care about. That output passing, which is what we saw TextFSM do, and a plugin system. Okay, well, unlike the M240, Trigger is flexible. Whereas traditional automation tools try and lock you into a DSL, Trigger is straight Python code. And you might ask, well, why is that good? Well, in my opinion, networks are quite complex, and sometimes the logic exceeds what a DSL has to offer. Most network devices are configured through VTY lines. They're not configured through binaries or configuration files. And let's be real, how many of you just said to hell with it and written out your intention in a bash or Python script and just called it with Puppet exec anyway? Now, this doesn't stop Trigger being used with other CM tools. For example, we do have an Ansible plugin. All right, so I'm going to go into the next demo. All right, so just taking off, continuing where we left off. I've sort of come up with like a pretty basic configuration management system wired up with Trigger. So what we'll do is we'll just grab some state from our network, and I'm just doing something really basic. All I'm doing is grabbing the ASN numbers on our PE devices, so that in our scripts we can then say, all right, well, we want to make sure that we're actually deploying it to the right autonomous system number and not something else, just something trivial. So that's our project directory. So here's our customer-specific data. So this could be anything. This could be like a CMDB or an IPAM tool, just anything. So this is where we're going to define what our tenants should look like. And with Trigger, we can pull in those values and then use it to build our candidate config. Okay, so yeah, that's that state that I pulled. It's pretty trivial. You could do more. So let's build the candidate config. So we're using Ginger here. So let's just first make sure that in our backups that we always take before we do any automation, that those tenants don't already exist, which they don't. Now let's have a look at the candidate config. So pretty standard like layer 3 VPN iOS configuration, if you're familiar with it. And let's have a look at the Ginger template that we use to one of the Ginger templates, the one we use to build the interface configuration. I'm not going to go through all of them. So yeah, pretty standard stuff. All right, so let's deploy it. All right, so I'm not going to show you the code just yet. I've got it up on a slide in a minute. But basically what we've done here is we've grabbed for every device, we've grabbed the candidate config. We've done a baseline, so we've just gone show all our VRF information. We've then deployed our config and then done the baseline again to make sure it is as intended. So as you can see here, we've only seen the VRF information once, so we know that it didn't exist before. We've deployed it and then now it exists. And we've done it for both PE devices. So I spoke about using using Gong to run commands on login. So I'm going to make use of that for the demo because you don't want to see me type in or try and fail to type in show commands. Okay, so as you can see, the tenant's pretty much working on this PE device. We'll just jump out. We'll verify on the second one as well to make sure it exists as we intended it to. Yeah, cool, it exists. So now, let's try and do the rollback. All right, so that's the rollback config. The cool thing about Ginger is we can have filters in there to kind of trigger when we're going to do a rollback or not, emit the rollback config. So let's just push that out. All right, so as you can see here, it's as sort of I explained before, we're only really expecting to see it once, so we know that it already exists, so we should only see it once. We've then run the rollback, and those warnings there are sort of what iOS tells you when it's starting to roll back the VRF information. It does take a little bit of time, so let's just keep logging into the devices until we can be sure that it's been rolled back. Cool, so the values are gone, but the VRFs are still there. They'll go away in a minute, but we'll just jump on the second one. All right, so that one's still rolling back. We might just have to wait a little bit. Cool. All right, so yeah, it's gone. So you could do something like, you could wire this up to like a continuous integration pipeline because as it's just Python code, it's not like a J2E monster. You can easily wire up to something like Jenkins and spin it out and make it fit into your environment instead of trying to bash the tool into yours. All right, so just rolling back that GoRC config. So what I'm going to show you now is just a new feature. It's experimental. So the feature is session persistence. So what we're basically doing is, so in the back end, trigger is asynchronous. So we're providing an interface so you can still write synchronous code and just inject commands into the asynchronous thread. And you can do interesting things. Like in this example, we're just going to run our script, which basically just tells us we're running in a while loop. We're going to probably be a little bit cheeky on our device and change the message of the day. So we're just going to tell the device that goes maybe a better language than Python. But then obviously our Pythonic overload tells us that we're not, and that Python's actually eat gophers, shut in, no. And we roll it back, and then the Python Lord is happy again. So pretty trivial, but there's a lot of power in that. So let's jump back. Hey, it came back good. All right, so recapping. In our deployment, we basically had a YAML data model which contained all our customer configuration values, our service provider configuration, which you didn't see it, but we did it. We compared it with what was actually in the network, and we compared it with our device model, which I'm going to go more into what the device model looks like in a sec. We deployed it with our simple commando runner, and something like this is really easily wired up to a CI/CD pipeline. Session persistence, for those that are interested, or it's experimental for one. For those that are interested, it uses the twisted crochet library to maintain 2 threads of execution, and allows us to write pretty easy code for something that's kind of hard, which is writing asynchronous code. So that's all the code, the synchronous code that we needed to do that. It looks pretty easy. You could probably make it a little bit cleaner. So moving on to the device model. So the model in trigger speak is the net device. And it's basically, you can define it in various different backends. So there's SQL, XML, JSON, CSV. You can even plug it into a third-party tools. So for example, there's an open source IPAM tool called NSOT, and we have a loader for that. So you can just have all your models defined in IPAM, triggers, and be able to pull that out, and you can automate against those. The model will contain metadata, so you could use that metadata to build unique data sets. So you can say, all right, I only want to target production devices, or I only want to target devices that are monitored, and you can use that as a search query and build a device set based on that. So that's what the model looks like. It's pretty just standard JSON, I guess. So as you can see, there's that ASN number in the model. So we basically, in our script, we just made sure that it was basically compared to that. So some of these attributes actually are used by the subsystems of Trigger to provide enhanced functionality. So the output passing that we saw earlier makes extensive use of the manufacturer info and the operating system. The make and the operating system. And that's because what we do is we want to reload the right template for a given vendor and for a given model. And because, like for example, with Cisco, they have a whole bunch of different operating systems with various different CLI commands. It just helps to hint at what template we actually need to load. Okay, so the next component I want to talk to you about is Commando. We've been through it a little bit, but go into more detail. So Commando essentially just abstracts away twisted internals. It's responsible for running you give it a list of commands and a list of devices, and it will go about running those commands on all of those devices. So you might think that, well, that's pretty rigid. What if I wanted to do something different based on some context of that device? Well, there's a whole bunch of methods that you can override. I call them to/from vendor methods. So if, say, you were automating against a Cisco device, you say to_Cisco, you'd override that, and you can do some logic there. So that's basically what I did in my example, in my demo before. That was how I was able to load the candidate config, and I'll show you that code in a minute. It also has the 2 results buckets. So there's the past results and the raw results. So that's the script or the code that we used in the demo. So you can see there's the to_Cisco method where we've overridden it, and we've just kind of used that get deployment config, which basically loads the candidate config from disk based on the device, and the candidate config text file was just the device name.conf. So it's pretty flexible there. And we've seen it before, but that's the text FSM, the structured output in context with the unstructured. So below you could probably recognize that from when you've run show IP BGP summary on a Cisco device, and basically that's what it looks like when it gets processed. All right, so the next component I want to talk about is Twister. So Twister is a transport layer. So as I said before, we have SSH and Telnet and some API level access like JuniScript. So the role of Twister is essentially just to dynamically choose the right transport for a device. So it does this, and this is the code that does it. So at the top, that's a private method on the net device class, and essentially it just peeks into the Twister API and pulls that it pulls the method out, binds it to that execute, and then every time it gets called, it passes the net device object in, and that choose execute function there will then take that device and return the right transport based on the context of that device. So the next component is TACX RC, so that was what Gong was using to do the credential management. So we can load the current user's credentials get stored in their Unix profile. So it'll prompt you, it'll say username and password, and then you put your credentials in there, and it'll serialize that to disk. There's two encryption methods, so we can either encrypt it with GPG or just a passphrase. And basically, it just stops you from hard coding your credentials, because that's a good thing, I think. So this is basically the workflow that I would suggest anyone getting started follows. So at the top there, we just define our model. In this instance, it's going to be in JSON. And then the net device there object will load that model. You as the user come in at the commando layer. So that's where you supply your device filter and your list of commands. And as I explained before, as the net device is in a way responsible for its own transport or selecting its own transport, commando will then just basically loop through all those net devices, open up the right transport, and then execute what it needs to do. All right, so I'm going to start digging into, I guess, the guts of Trigger. So Trigger makes use of the SSH client Conch. So Conch is the SSH client found in the Twisted API. And where this is different to alternatives like Paramiko is that Conch gives us the ability to automate many devices seemingly in parallel. As I said before, Trigger is built on top of Twisted. And for those that don't know, Twisted is an event-driven networking engine, also written in Python. It makes use of the asynchronous networking features found in most modern operating systems. So on Linux, that's EPOL. On BSD, that's KQ. It contains a robust set of networking protocols like SMTP, HTTP, SSH, and DNS. All right, so some of the building blocks that we use out of Twisted are protocols. So a protocol is basically is responsible for our data channel. So we're able to override some of the default behaviors of, for example, the SSH channel to account for some inconsistent vendor implementations and for the absence of end-of-file signals. So we're able to do that by sort of doing prompt string matching instead of expecting an end-of-file signal, which is what you would normally do in like a bash-like environment. And where some instances where a vendor has done something strange with SSH, for example, some Cisco SSH servers actually don't initiate the key exchange process once the client is connected. They expect the client to initiate it, which is really bizarre. The other thing that some of the other components are factories. So a factory is basically responsible for standing up that the protocol for a given TCP connection when the connection is ready. So this gives us some pretty cool hooks. So we can do things like reconnect on a disconnect and persisting data between sessions, because in the Twisted world, the protocols themselves are ephemeral. So any data you have there, if that goes out of context, it's lost. So we can start writing that back to the factory itself. All right, so the other two things I'm going to talk about are defers and callbacks. So those familiar with Node.js or might know what this is. So it's essentially a deferred is a promise that some data is going to exist in this area of memory in the future. And a callback is a user function you can register on that to get called when the data exists. And the first argument to that callback will be the data itself. So this is interesting because it allows us to do things like handle errors as they occur and not later down the track. It also means that we can change the way we execute or perform actions based on the context of the data that's returned from running our commands. All right, So all this talk of deferreds, factories, and protocols sounds complicated, right? Isn't it easy enough just to read a device list from a text file, loop over each device, and just be done with it? Well, imagine you're trying to automate a network of devices, and let's say we've got like 1,000 devices, and they're all connected by circuits of varying quality. So you might have some on fiber, some on ADSL, some on terrestrial satellite. Iterating through all your hosts using a Paramiko-based library, that would cause unnecessary delays to your devices on faster circuits from being updated. Now, this is because Paramiko's concurrency primitive is threading. As you know, Python, you may or may not know, Python suffers from the global interpreter lock, which essentially prevents these threads from ever executing truly in parallel. On top of that, the native networking polling functions used by Paramiko cause delays due to their synchronous nature. Trigger's use of non-blocking sockets means there's no waiting for slow devices. Each transaction it fires off, instead of waiting for a response, it moves on to the next thing. The request, obviously, as we talked before with deferreds and callbacks, has a function assigned to it, and that takes in the data when it's available, so we just keep moving on and on. Now, you could do things like, you could mitigate this with worker queues or multi-processing, and then do selective ordering, so you could maybe send all your fast devices into one queue, all your slow devices into another queue, but then you have to keep track of how slow each device is offline. And what if one of your faster devices is currently being impacted by an environmental concern? Maybe one of these devices is getting DDoSed, or there's some, it's a bad link and there's some packet lost. That would still cause, that device there would still cause all your other fast devices, would slow them down in getting updated. And on top of that, you now have to manage like extra complexity with more infrastructure to manage those queues. You could also do things like rewrite the whole thing in Go, or use different libraries such as async SSH, but you kind of lose all the work we've done around handling all those vendor inconsistencies. All right, so I spoke about netconf. Netconf is the IETF standard for interfacing with network devices programmatically. So with netconf, we move from box-by-box configuration to like a more declarative model-based way to manage network-wide configuration. So with netconf, you basically speak to your devices with XML via an IPC over SSH. And now you might be thinking, well, XML sucks, and you would be right in thinking that. So hopefully the device will inform you how to format your XML via a series of schema files, and these are defined in Yang, which is a modeling language, and it's similar to SNMP MIB. Well, if the device doesn't let you know the schema, it's basically left up to you to decipher the API for yourselves, so hopefully the vendor has given you some documentation. So I'm not saying that netconf isn't great. I think the ability to model your network configuration instead of box by box is like where the future is going. But can I safely say that it covers all my requirements today? No, I can't. So this makes CLI automation, in my opinion, all that more important. You most likely aren't going to upgrade all your eligible devices to code bases with proper netconf support. And for your older platforms which do not have APIs or netconf support, you're basically left with no other option. All right, so we're getting to the end of what I have to say. So I'm just going to run through getting started with Trigger, because the installation and configuration phase is something that's tripped me up in the past. So for those getting started, they can come back and reference these slides, and if they want more detail, they can go to the links at the bottom. So to install it, basically it's either through PyPy or from source. You create your config directory, and this is normally going to be pointed at by an environmental variable that I'll show in a minute, or the default is just in etc. So one thing that got me was you basically need to download the tarball from the internet, from the GitHub page, and there's a bunch of boilerplate templates in there that you need to then copy into your config directory. So this is the list of template files that you need to copy. So you need to copy the settings.py file. You need to copy the net devices JSON. So settings is basically just the standard settings that you're going to use. The net devices JSON is basically just a net device model that you can kind of start off with and manipulate and then use as a base. TACX is the file which contains the passphrase encryption, which is the default. So if you don't have that, then you're not going to be able to cache any of your credentials. Bounce.py and ACL.py are they're used by two of the plugins. So I'm not going to talk about them, but Bounce.py is for fitting into change windows. So you can know when the right time to automate is based on if you've got an open change record. And ACL.py is a plugin that you can use to do sort of ACL normalization, which is, I guess, another topic in itself. So with settings.py, as I said before, it's pointed there, or at that environment variable trigger settings. This is where you can do things like configure prompt matching. So this is pretty cool because a lot of network vendors actually like to emulate Cisco's CLI. So if you've got a device that is sort of Cisco-like but we don't support it, you might get away with just configuring if they have any strange prompts. You just put the prompt regular expression in there and it might just work. You could do things like configure the plugins, so you can configure those 2 plugins that I mentioned before, and there's a few other ones that I'm not going to go into the plugin system in this talk. You can configure where your net device sources live, and so obviously they can live in different areas, like you can point to a JSON or from a custom loader, so that's where you can do that. And there's a bunch of defaults, which is maybe a gotcha, so maybe if you are referencing this, go back and check those defaults to make sure that everything is okay. So I'm going to finish off with just some pro tips for using Trigger. So baseline your state before and after you do a change, which is probably good change management practice anyway. Use the interactive Python mode to inspect the variables that you're working with after you run a commando loop. So like debugging asynchronous code is really hard. So in the interactive Python mode, if you're doing everything in the main namespace, all those variables will be left over and you can sort of inspect what happened and what their values are instead of just doing print statements everywhere. So try and use the commando model instead of doing the asynchronous way, the twisted way, which is kind of when I showed you the session persistence code example, that's kind of doing it the twisted way. I guess the value of doing it in the commando way, just subclassing commando and overriding the to and from vendor methods is you just encapsulate your code a bit better, it's easier to read. And test against simulated devices. So in my lab, I'm using GNS3, but you can use tools like Cisco Viral or UNetLab to just spin up virtual network devices, and then you can do all your development in that instead of having to buy a $40,000 switch. Cool, so thank you for listening to me. There's some more info there. That's the GitHub page, some docs, and we have a community channel on the Network to Code Slack channel. So if you want to talk more about Trigger, you can jump on there. Thank you. Is there any questions?
Having tried to write things like this in the past, one of the things that sort of catches you out is if there's something on the device already that's inconsistent with the config that you're trying to apply. And so part of your config applies and part of it doesn't, particularly like Cisco devices.
Yeah.
Do you have anything to sort of gracefully back out of that situation?
No, so I guess with Trigger, we're basically just like the conduit for you with your own policies. So some Cisco devices do like transactional updates, so maybe you might want to look into that. So it's actually a sneaky hidden feature in one of the later iOS 15 code bases. So you might want to look into it. It's something they don't really advertise, but definitely in like Cisco's carrier routers, they'll do transactional updates, and you probably want to work more into that. And that's what netconf works in that sort of model, doing transactional updates. So, yeah. Any other questions?
Is there any plan to work with or integrate with any of the other open source projects like Napalm?
So we've toyed and sort of tested out maybe using Commando, call and use Napalm as a transport for certain instances where it makes more sense. Like because Napalm has a much better configuration management model than what we do. We're just really the conduit for your own policy. So yeah, there's definitely stuff we've explored, and but a lot of those you would lose the asynchronicity doing that way. So it's sort of like you gain something, you gain really good configuration management, but then you lose the speed, which you might, fitting into a tight change window might be hard with something like Napalm if you have to update 500 devices all in one change window.
No one else? Oh, yeah, go on. Again, kind of related to trying to do this in the past, if you have two sides like a primary and secondary router that appear, and you don't want to change both of them at once, do you have any way of sort of implementing that interlock so that one has to finish updating successfully before it starts on the other one?
Yeah, so I showed you the session persistence before. That would be the easiest way to do that. So you could just have like a really basic while loop, and you could run the command on the first device, and you just keep polling, and you poll the results that come back. Or you could even because it's twisted, you could just register a callback on the promise that comes back from that first command, and then your function.
Start the second one when the first one notifies
Yeah.
it's done.
Yeah.
Cool.
Well, if there's no further questions, then please everyone give another round of applause to Tom.
Cheers.
So up next we have Josh Simmons in about